So what is modification? What does it mean when we modify something?
Changing something.
Change, right? Change. And in this case, we're saying it's a change in allele frequency, so it's change in traits. And it's from one generation to the next, generation to generation. So that's our definition. This is one of many definitions of the evolution, but this is the one our book is using. So we just defined evolution. Now the rest of the chapter is going to talk about how evolution happens, who is responsible for the theory of evolution, and which people contributed and how they found evidence for evolution. So that's what this chapter is talking about. I think the name of the chapter should be natural selection, because most of it is on natural selection. So we're gonna talk about things like why this giraffe has a long neck. Maybe the trees got too tall and it needed to stretch its neck in order to get food. The ones that couldn't stretch the neck, they died off. And the ones that adapted, the ones that had the long neck trait, they lived. Another question might be, why these flowers have such a heart shape? Why do they have this shape? Anybody wants to, maybe come up with an explanation? Why they might have this shape? So try to think of an explanation that might be valid for them having this shape, may be needed for them having this shape. Maybe take a guess. No one? So how do flowers pass their genes? How the genes are passed on for flowers?
Through pollination.
Pollination, right? So maybe this shape is needed for a specific pollinator. Maybe they find this shape attractive and they come to the flowers and that's how they get pollinated. So maybe that's why they develop this shape. That'd be one explanation for this. So evolution is going to explain the features of all organisms from microbes to humans. So when we're looking at a trait, we can't just say, for example, here this one giraffe has a long neck, so that's why because this one giraffe has a long neck, and that's because the trees got taller. We have to look at a group. We have to look at a population. So you can look at one population of giraffes in one area, another population of giraffes in another area. Maybe they'll have some different traits, or you could look at two populations together. So you can't just look at one individual and decide this is a trait and it's going to be passed on. You have to look at a group. You have to look at a population. And evolution is going to happen when allele frequencies change, so this allele frequency is going to take you back to chapter 10. We did a Punnett square for chapter 10. And let's say we did a Punnett square for this, and we had a big R for red, and we had a small r for pink. After you did the Punnett square, maybe you got the allele frequencies 50% red and then 50% pink. So after maybe doing the Punnett square, this is what you got. So these are your allele frequencies. Next generation, these might change. Maybe 60% is going to be red and 40% is going to be pink, or 75 is going to be red, 25% is going to be pink. So this change in allele frequencies is what tells us that evolution is happening. One color is being favored over the other one. So those are allele frequencies. This is important because this is how you calculate the allele frequencies. So number of copies of an allele and then total number of allele for the same gene in the population. So let's say we have a flower population of 100. So we have population size That's 100. And there are two possible alleles, red and pink. So we have two possible alleles, red and pink. So how many total alleles are there? If each individual can have two possible alleles, either this one or that one, how many total if they're 100 individuals? Double that, right?
Double, yeah, 200.
200. And I'm just picking a number, you know, this is, I didn't really count the flowers. I'm just picking a number. I'm gonna say 160 are red. Now let's go ahead and apply this. Number of copies of an allele. So I said I counted and it was 160 red. So that's our top number. And then on bottom, total number of alleles for the same gene in the population. What was the total number of alleles?
200.
200. So you're just gonna divide that, and I think that's gonna give you 0.8. That's your allele frequency for, you know, this allele here. And you could, you know, maybe have another population. I'll just do one more. That's 50 individuals. We still have two possible alleles. And total, what is the total alleles here? If for 50, there are two possible alleles.
100.
100. Now you guys give me a number, maybe for the red allele. How many are red? Looking at the chat. 60. Camellia said 60. 60 are red. So we want to know the allele frequency for red. So we're going to take 60 divided by total, 100. Whatever you get after dividing, that's your allele frequency. Does that make sense? I'm not going to have you count anything. I'm just going to give you the number. If I ask you this on the exam, I'll tell you this is the total number of population. This is the possible alleles, and this many are red. So you're just going to apply this. You're going to divide it, and you're going to get the allele frequency for that. This might be difficult for you to understand if you don't understand chapter 10. Okay, so evolution is detected by examining the gene pool. Gene pool means the entire collection of genes and alleles. Let's say this is the population for San Jose. So for San Jose population, we only have Caucasian people, and they have blonde hair and blue eyes. And this is the population in Asia. They have dark hair, maybe a little bit darker skin. So the gene pool for the San Jose population is going to have alleles for blonde hair and blue eyes, whereas the gene pool for the Asian population in Asia is going to have darker hair allele, darker skin allele, different features. So if there's no mixing of these two populations, then these are the only alleles available in San Jose, and these are the only alleles available in Asia. So the entire collection of genes and alleles. So the possible alleles available in San Jose population would be blonde hair for hair color, blue eyes, light skin, and then for people in Asia, the alleles might be available for dark hair, dark eyes, a little bit darker skin. Unless if there's a mixing of this population, the allele or frequency is going to change. There is going to be mixing. So some of these people might have blue eyes then, and they might have blonde hair. But when we're looking at the gene pool, it's the entire collection of genes and alleles. Next slide, showing you population of Scandinavian people here, and then Asian people here. So gene pools differ from population to population depending on what alleles are available in that population. So this population have different gene pool compared to this population here. And it might be because where they're living. So maybe there's high UV radiation in this area. Therefore, they have higher number of melanocytes in their skin because the place they're living at, and they have a little bit of darker skin. And here, maybe there is less UV radiation. They don't really need that many melanocytes. So over time, these populations can diverge in different directions. This population can have even darker skin color in the future, and they can even have lighter skin color in the future because of the climate or because of the environment they're living in. So they can diverge in different directions unless maybe there's a mixing. So I'm not really up on the history, but I think we got planes, I don't know, 150, 200 years ago, and humans been around for 2 million years. And then we got boats maybe 15,000 to 10,000 years ago. But if you compare those numbers with how long humans been around, that's nothing. But those are some of the things that allowed us to have different variation in the alleles. So if Swedes migrate to Asia, because we can go to the other side of the planet now, in a day and a half, and interbreed with the locals, and the allele frequency in the gene pool will change. They will have some alleles that's for different color of hair, different color of eyes, different color of skin. And that's going to tell us that evolution has occurred. This was not possible before, because, maybe a million years ago, because of these waters separating these lands, and we didn't have modern travel. It was harder to get from one side of the planet to the other side, but now this became possible. So there are not, I mean, there are some, but it's very difficult to find purebred people. For example, maybe Mayans and Aztecs in Mexico, they didn't look like, the Mexican people right now. They had different traits, they had different alleles. So it's hard to find now purebred indigenous people because of all the mixing that has occurred. But it's not as much if you think about how long humans been around and how long the modern travel been around. It's not very long. So I have a question for you guys. Which of following can evolve according to the biological definition of evolution? This is the biological definition of evolution: descent with modification. Those are your options.